Okay, good morning. I welcome you back. Hope you had a good holidays. Did you?
Yes.
Okay, that's good.
Very
Okay,
busy.
very busy. So this is lecture 8, and today we will discuss about relational databases, and this is very important for your second assessment because you would be building on relation database for your assessment too. Okay, so first I will be happy to answer your queries if you have regarding assessment 2. Did you go through the assessment brief? Any questions, queries? No? So first of all, as I mentioned you in start of the semester that I'm teaching this course a third time and I am updating contents every time I deliver this course. So last year when I was delivering this course, I updated most of the contents from previous version of Visual Studio to 2015. So if somewhere in lecture slides or assessment brief you read it has to be done 2015, so don't worry about that. If you're using 2017, you can do all the activities and your assessment in Visual Studio 2017. Okay. So ignore the 2015 if you read it somewhere else. Okay. Okay. So in this assessment, first of all, you can see that there are 5 modules you need to build. Login module. There is one example which is available on the Blackboard next week. We will go through it. But one student posted on the Blackboard. I think it was not very useful. So I will provide one more example regarding login module, how you can log in and create sessions. So I will provide you information or maybe complete code for this module, so you don't need to worry. And I recommend you in your assessment, first of all you work on 4 these modules first, and in the end you implement login module, because in login module you just have to, after login you have to enable and disable the menus so that one user cannot do anything which is responsible for the menu. So leave this module for the end and start working on the rest of the modules. And reports management modules is basically repetition what you did in your first assessment. Okay, in your first assessment you receive the information from the previous form. In this case, when you need to generate reports, you will receive the information from the database, and from there onward the logic which you used in your first assessment can be reused to sort the information, calculate the medals. You can use queries as well. We will see some examples of queries, or you can use your previous code as well. So at the end, initially you will be doing most of the time coding for these units, so you can spend more time on these and then you can move forward. So if you have any queries, you can post them on the Blackboard, or you can email me as well. So regarding login module, you don't need to create, edit, delete. So I have mentioned it over here, and you can just hard code this information in the database. Okay, and again next week I will provide you. We can discuss it more. So games management module will have information about games, and I have asked you to upload a PDF file. It can be any dummy file, even blank PDF. You just need to provide upload functionality. So whenever user is adding a game, there should be a file control, browse the file and upload the file. Okay, so you don't need to create some description that this game is cricket, it has so rules, not required. Okay. You need to at least 3 games. Okay, so when I'm testing your application, at least I would have some information. I don't need to add information to your database. Regarding competitors, I have mentioned at least 25. I forgot to change it. You can have at least 5 competitors information. Okay, I will basically make an announcement on the Blackboard that regarding this. So at least 5 competitors information should be you store in the database. Okay, so I have provided, again, photo is a type of file. So whatever you do with the PDF file, you can use the same functionality for photo upload. Events management, okay. And then this is reports management. So if you have any questions, do get touch with me as soon as possible. Yep.
Is it okay to use like this website called Discuss? There's a lot of templates similar to assignment 2.
What sort of templates? Programming templates or?
Like connect from backend, my SQL to the web page, the client end. There are a lot of prerequisites.
That's fine. If you browse a web, you will find a lot of information. So I'm not restricting you. You go and consult the resources and you can use that code. Not at all. No issues. Okay. I'm not restricting you. You need to understand that code. It would be unlikely that you copy paste entire code and your entire application would be working. It's unlikely that there is one application that's if you find that one, then you will not learn anything. You may get advantage, but you're open. You can look at that code and you can implement in your website. That's fine. That's no issue. Important thing, you should understand what's going on. Okay. For example, login module. I saw last time students struggled. It's very simple. I provide some guidelines, but students were not able to implement 100%. So this time I decided I will give you the code. Okay. So next week I will give you the code that this is how you get user get authenticated, and after that this is how you can use the session. Now you can use this session key on next few pages, and again next week we discuss about session as well. So I will provide you more information next week. Okay, so no questions regarding databases. As I mentioned in the assessment brief, you can use Access database, you can use SQL server, which might be running on local machine or remote machine, or you can use MySQL and so on. Okay, so it's up to you. If you have experience with SQL server, you know store procedures, you know how to create views, you are open to use that. Visual Studio also provides you capability to create database within this Visual Studio environment, and I have provided you. If you go to your this week module, you see I have one PDF attached over here, and this PDF provides you information. Basically, you create your web application, and the way we add forms, which is new item. Similar fashion, we add a database. So instead of when we select new item, we go and select we click the data menu over here, and we select SQL Server database. And I have provided the steps over here. You can see when you add, you will have database over here. You can rename this database as per your requirements. And then if you open this database within Visual Studio, you have a Server Explorer, and database will be visible to you. You can create new tables by clicking right on the table menu, and you can create tables. And this YouTube video basically provides you information how you can create tables and how you can apply constraints on those tables and so on. Okay. So if you have any issues, do post them on the Black. Okay, so today we will look at the relational database management systems. In assessment, I have provided you almost normalized database. The fields I have mentioned, they are almost normalized. But if you want to further normalize them, you can go ahead. If you can combine them together, it's your choice. Okay, so you have flexibility to modify the design the way I have provided you the fields. Okay. So relational database, today we will look at the concept of relational databases and the function which are provided by database management systems, like creating databases, identifying primary keys, understanding the operations we can perform on the database, such as adding, deletion, and writing queries to retrieve the information. We will also try to understand what sort of relationship exists between the tables and why those relationships are important for us for our understanding. We will look at one poor database design, and we will see how it leads to different anomalies. What issues we come across if the database design is not poor. And normalization is the process that is step-by-step improvement to your database design, so that eventually when you finish your database design, it would be normalized. Okay. And we will also look at some performance and security issues related with the databases. So we all know what is a database. Database is collection of tables, and tables is collection of records, and each record basically consists of fields. Okay, so with characters we represent fields, and fields records, and tables. Tables are also called as file as well. And mostly it is a third tier in web application. So you know three-tier architecture. So in three-tier architecture, basically web application, front tier is basically graphical user interface. Okay, GUI. Second is business logic. Okay, business logic. And third is database. So that's why it is called as third tier. Okay, so graphical user interface retrieve information from business logic, and business logic retrieve information from the database. Okay. And this is a typical example of a table. Okay, we all know that we have records and each record should be unique in a database. Okay, and why we have this relational database style or management system? We want a centralized storage of information, a central truth, we can say that, so that each and every application should consult this database where we have consistent information. So what issue we used to have before, that each software which enterprise build, it will have its own database. So at the end of the day, the enterprises end up with many information systems and many databases. And there was no centralized truth which can be consulted when they retrieved information. So it led to many inconsistencies among the information systems. So relational database management systems basically introduce consistency into information storage within enterprise. So do you know any database management system that store information in non-relational format? Have you heard of NoSQL? So in case of big data is huge amount of data that could be structured, unstructured or semi-structured. Now that data cannot be stored in this format. Okay. So for that we have databases that are called as non-SQL or NoSQL databases. And in those databases we store information in this format, key value pair. Okay, like dictionary you use in your for example. So in this in using this saving information in this format, you basically compromise the consistency of information, but you basically achieve availability. Okay, so if you have redundant information that may be inconsistent, but information would be available. Okay, so in big data applications, consistency is not what we want to achieve. It's not top priority. Availability is top priority. Okay, so if one of you would be doing research in honors, or then it could be a good topic to look at non-relational databases. So it's related to big data, Hadoop, those technologies come into the play. So when we have tables, we do need to identify each record uniquely. I'm sure you would have heard of primary keys. All of you? Anyone who did not hear about these? Okay, so primary keys are the keys which is a column within the table that can uniquely identify a record. So can you identify which could be primary key in this table? This is a telephone book table. So which?
Probably actually, well, depends on, you could use, phone number.
So
Phone number would be good.
Which one? Phone number, yeah. Phone number is good primary key over here because it's phone directory. And it could be a good primary key candidate for primary key. Okay, so we can use it. But as you said, we maybe think if there's an Abbott whose first name is maybe John, son of Abbott, who's living at same address and he's using same phone. Okay, but in telephone book, this is okay. There's one phone because from phone key we are differentiating the records.
Can't you make a primary key from like two separate columns?
We're going. So sometimes it's not possible to create a primary key from one column. So we may combine two or more than two columns to create a primary key that can uniquely identify a record. So in that case we call it as a compound key. So compound key is a primary key which consists of two or more than two columns. So in this scenario, phone could be enough. So now let's look at database management systems. So how we can define DBMS?
Create databases, edit them, store them.
So these are the software that provide you all the capabilities you want to play with the database. Creating tables, writing queries, updating information and so on. So all these functions which are listed on this, the things which we do with the databases, this is specialized software. Okay. So this is a PHP MySQL interface to create databases. Similarly, when you will create Visual Studio to create a database, I have shown you a screenshot. In Solution Explorer, you have tables. When you right-click create new tables, you will provide it a graphical you will provide an interface where you can create tables and so on. Similarly, Oracle has their own interfaces that help you to do all these tasks on the databases. Eventually, databases are also files. So these database management systems basically work on those files, and to you there is an abstraction layer. For you, things look very simple, but behind the scene, these DBMS, they are doing a lot of jobs on behalf of the user. Okay. Especially, we also have distributed database management systems, databases that are distributed, and one software which is distributed DBMS basically manages all those and gives you a single view of those databases. Okay. So, creating a database requires a lot of planning and analysis. What do you think? What sort of planning and analysis we need to do? Relationship between what?
Normalization.
Entities. What sort of entities are involved? And when we say entity, what do we mean by entity? Anything about which
We want to solve.
we want to solve, we want to process information, we want to record information. If I say you, if we need to create a database designed for course management systems, what do you think? What entity would be involved? Students, courses, staff. So these are the entities. Okay. So first of all, what data to store? And this is about entities. What entities are involved? If you identify the entities, then you can identify the attributes of those entities. Okay. Then how to divide the data between tables? So you have identified the entities. Now how tables would be designed? So should we have a separate table for each entity? This is normally a good practice. If you have entity, you should have a separate table for entities. It's not good that you combine student entity and course entity into one table. There should be,
You lose the law.
yeah, and we will see some issues today. So this is general rule that each entity should have its own separate table, at least. Okay. So how to divide them into table, and once you divide into the tables, then what sort of relationship exists between those tables? Okay, and we will see some examples today. So this sort of planning and analysis you need to do. And so as a result of this planning analysis, when you creating a table, you basically identify what sort of column you need and what will be the data types of those columns, what sort of constraints you need to apply, what should be the length, and the length constraint should be within the database, or it should be application level, or it should be at both level, and so on. So these decisions you need to take on during this process. So once you are able to identify a table, you are able to design a table, what should be the primary key? So identifying a primary key is a bit challenging task, because once you are able to design your application, design your database and then application and then deploy it, then afterwards if you realize that, oh, this is not good a primary key, now there are some issues coming in, changing that, making that change in the database will be a difficult task. Okay, so that's why it's very important to see it.
Off topic, you know you get primary key and foreign key.
Yep.
What does AK stand for?
AK?
Yeah, like alphabet A. AK.
Alternate key.
Sorry?
Alternate key.
What is it actually?
We will discuss. We have primary keys, we have candidate keys, we have alternate keys. So in one of the example,
Pretty much something like identification key.
yeah, alternate key is any. Okay, let me. For example, in this table, these are all candidate keys. That could, not all, but these two are candidate keys that can potentially be a primary key. Okay, so a key which can be a primary key, we call it as a candidate key, and the key which is not a candidate key, we can call it as an alternate key. Okay. So these are different names given to this. Okay, so identifying a primary key is a challenge. For example, we all know that your student number is your unique key, no matter which information system university build. Your student ID is a unique key, and it would be referred wherever we need your information to be stored. Similarly, social security number or whatever is used in Australia. So in all MyGov records, that will be used as a primary key. So let's look at this example now. In this case, assume this is an insurance company, and these are the clients of that insurance company. So now, keeping this in context in mind, now what do you think it would be a primary key in this table?
Nothing.
Nothing. Do you agree with it? Yeah. Why? Because there could be another abbot whose first name is William, who lives in the same house, and they share, this is landline phone, and they share the phone.
I may not have a phone.
They may not have a phone, yeah. Yeah, they may not have a phone, because this is insurance company. This is no more a phone, yeah. So it's quite possible that there is no foreign key. Okay, keep that as an exceptional case. So yeah, so in this case, it's quite possible that, for example, in this case we assume that there is an Abbott and his first name is different. So in this case, all four together will be combined to become a primary key. So we have a compound key over here. But extreme case scenario does exist in which we don't have even compound key. We have repetition, but that repetition in real world are two separate persons. In database, it looks like a repetition. So how we solve that issue? So what we can do? We can generate a primary key. Okay. So if we come across this extreme exceptional scenario, we can create a key. The question is how to create that key. Or we can use some hashing algorithm that basically takes into first two characters of last name, then first name, then address, and then so on, and it add timestamp and create a hash. But there's still possibility of conflict if both of two persons came at the same time. So in that case, a system can generate an auto key. And one example is cities. So if you have cities, you have this table, you can generate auto key, and you can use this key in child tables, the tables which use this as a foreign key. We'll see what is foreign key on next slide, I think.
Another question, you know, you from the database, so let's say it's at category ID number 2, and you're using like identity for your, whatever it is, and you know how to increment, which is 1. So if you delete category ID 2, and your next value, how do you get it so it actually reads an empty value, you know what I mean, rather than just keep going along that list?
So yep. So what the question is, if this is auto increment, and you are adding a product, for example, and product order number is auto generated, then how you can basically use that product number in child tables. For example, we have order tables and order details table. Order tables ID is auto generated. Okay, and we need this generated ID in order details table because that's a child table. Then we need to retrieve this. There's a query in SQL which is max, and you can put in column number. For example, max ID, then it can return you the maximum key. Okay, which is next in auto increment. So using that SQL statement, you can retrieve the key.
Is that the next key that's available?
Yeah, so you can use that key, and then you can insert data in this record, and then you can go and you can use that query to retrieve it, and then insert into the order details. Okay, so this is a way where we generate a key when you don't have primary key or compound key in existing table. So this is an example which we have multiple column key, employee ID and project ID together. They identify a unique record in the system. Okay, so you can see that employee can be involved in different project. So employee ID and project ID together act as a compound key, and whenever we add information, we have to ensure that these things are not repeated. So one of the characteristics of primary key is primary cannot be repeated in that table. Primary key is unique in that table. Okay. So we know what is primary key and its role. What do you think it can be used for? Joining tables, yes. What else?
All that.
Yeah, all that, yeah. So when we are adding information, primary keys help us to ensure database is consistent. There is not redundancy in a table. Okay. For example, student ID. We cannot add duplicate IDs. Student record would be unique. So they help in this fashion. Sorting. Again, these are numerical keys most of the time, and they can be indexed, and sorting can be done. And I will show you some examples on upcoming slides. And these are very critical to create relationships. Okay, and they are also important when we are normalizing the database. Okay, again, normalizing relationships we will come. We will discuss in a few seconds. So how they help us to basically, primary keys help us to avoid redundant information in the database. For example, if you have a student email address as a primary key, and you are trying to add a new student which has the same which is you think a new student, but the email address already exists. So if you try to add it, database will give you an error because you cannot have a duplicate information against that primary key. So there are different ways to handle it. Instead of database return you the error, and if you don't have a try, catch, exception handling, it's better you should check first before adding the information whether this email exists or not. If you query the database against that email and you get a result, you mean other users already registered. If you don't get a result, then you can go and add new record in the database. So the relationship which I am talking about between tables, because if we discussed that if you are developing a course management system, there are different entities. Now those entities have some relationship. Students basically enroll in courses and staff teach those courses. So there is a relationship. So those relationships basically are captured as referential integrity constraints. Okay, it's not possible that a student can teach a course, for example. Okay, so some of these rules can be applied at database level, other can be applied at business logic level. But anyway, let's look at this simple example. We have a student and this is student information, and this ID key over here is the primary key. We have enrollment table and we have this student ID as a foreign key over here. So whenever we have a primary key, that is ID over here, we identify in certain table that's primary key. If we use that value in some other table, then we call it as a foreign key. If value of a primary key is used in other tables to refer to certain information, we call it as a foreign key. And foreign key can be repeated in that table. So this ID is foreign key over here, and then we have enrollment information that maybe this student enrolled in undergraduate first, and after completing undergraduate he can enroll in postgraduate. So this is a simple relationship between these tables, that one student can enroll multiple times in different degrees. Okay. Now, is it possible that we have a record of a student in student table and we don't have information in the we have a record in enrollment table and we don't have information in student table?
No.
No. If we don't have student information over here, then no information should exist over here which is referring to a student which does not exist. Similarly, if we have a student over here and it is enrolled, we should have that information over here. So these are referential integrity constraints. If I delete student information over here, then all the records of that student which are being referred over here should get deleted. But what if I delete enrollment from this table? Should student record will be deleted? No. So these are the referential integrity constraints. If student is deleted, all the child records of that student which are in this table should be deleted. But if I delete the child record, then parent record should not be deleted. And all this happen only when you have these constraints implemented in the database. If you don't define these relationships in the database, okay, so these relationships does not happen automatically in database. You have to define these relationships. Okay. So these relationships on one side help us to basically maintain the database consistent. They also help us to reduce the redundant information in the database. So instead of using all this information into second table as well, we just referring the student using ID. So it reduces redundancy. So the question is where these constraints should be applied. You can apply these constraints at database level, or you can apply on your application level as well. So at application level, you can apply all these constraints. That if user is issue a command of delete from child table, make sure that, for example, if at business logic is to delete a record from student table, make sure that the delete query will also delete the records from child table. So you can ensure at business logic level, or you can apply database level. And if they are applied at database level, as soon as student is deleted, it will also delete the child records. Okay.
So is that what your class on? So like if you delete the game tab, so it's swimming, you delete swimming, then it deletes all the records there when they're computed in swimming.
Yeah. So it will delete all, and if I recall correctly, you have to basically in command you have to mention cascading something.
Yeah, I think
Okay.
it's cascade delete.
Yeah, cascade delete. Okay. So if you implement at application level, then there is a portability. If you move application to some other databases, constraints are there. But if you apply at database level and you move your application, then in another database, for example, you switch from DB2 to MySQL. Then in MySQL again you have to implement all those rules. Okay, so there are pros and cons. It's better to apply at application level, so you will have more flexibility when you want to move your application. So there are some issues which we should be taking care of when we are working with primary keys. Traditionally, there were some applications where this user is a knowledgeable user over here who basically admin in certain organizations, and he is basically registering the user. So it was possible that he is the one who is adding the user ID. Now this user ID may be coming from some RFID tag. Maybe each user has been assigned a certain card, and whenever he needs to be registered, he basically show up his card, and we scan the card, and that ID comes over here. If this is the case, then that's fine. But if user is typing in the ID, then this is not a good practice. Instead, what it should be that you should be adding the information other than the ID, and ID should be left for the database to be generated, or it could be some algorithm that can generate the ID. Okay, as we discussed before. Okay, so this is how you should be careful when you are working with the primary keys. Okay, so with database, we all know that we need to add records in the database. We need to delete and update, especially lab 4 and lab 5. You basically did it using programming. Okay. So whenever you need to add in a record, you have to be careful that the data you are adding is consistent with the design of the table. If date has been specified as a date time, then it should be in a proper format. If name has been in database design is set as a string, then it should be a string. It should not be integer. Okay, and so on. So data type should match, and it might possible that you set at design time, you set that the column should not have any blank values. Okay, then there should be some value that should come into that column. So in short, all the constraints that you apply at database level, when you are adding data, you have to be very cautious that the information is adhering to those constraints. Similarly, you can add you can delete record from the database, and be careful when you delete the record. Your query should be accurate. Delete from table where ID is equal to this, because if you not add ID, it will delete the entire table. Okay. Yeah. And using these operations, objective is we want to make data consistent all the time. Whatever transactions are happening, they are updating the databases, and the current state of databases reflect what your business is doing. So you want to keep database consistent all the time, because this is a single central source of truth for the entire enterprise. So we should be very careful. Whatever operations we are doing, it should leave the database in consistent stage. So as I said that on database we have a very powerful query language, which is SQL, structured query language, and using this query language we can basically retrieve the information from these tables in very efficient manner. And we have used these queries in lab 4 and 5. If you look over here, there are functions available within SQL that can give you some aggregate values. For example, select count from products. What it will do? Counts the products and give you a number. If there are 30 products in a table, it will give you 30 as an outcome. So it counts the number of records. If you want top 10 records, then you have this. You can have these keywords, select top 10 from these, and you can do order by as well. Okay, and ASC basically ascending from A to B, so on. You can also group again aggregate functions like. For example, we have a table in which we have products, product 1, 2, 3, 4, and all those 4 products belong to one category. Product 1, 2, 3, 4, all they belong to category 1. So, and if we want to retrieve information from this table, group by category, we want to see that against each category how many products are there. Then again we need to basically first of all select category ID, because this is what we want to retrieve. And against that we want to count product IDs. Against each category how many products do we have, and we are giving a new name to this column as product count. From products, group by category ID. Okay, so group by is a class which will group up all these records in a table. As I mentioned, there is product 1, 2, 3, 4, and all of them belong to category 1. So against category 1, 4 will be its count. Okay, so over here, if there are 12 records against category 1, we have 10 records. Against category 2, we have 12 records, and so on. So this group by class basically giving us aggregate results. Okay, if you have table like this, then this query can be used, and you can also add further checks on that group by class. For example, having count greater than 10, then it will restrict these results further to those counts where value is greater than 10.
Can you go group by category ID ascending?
Yeah,
Yeah.
you can use that. I'm sure you can use that. Yeah. And also you can, there are built-in functions within SQL that you can format the information. For example, over here you see it select product name, price, and it formatting the current date. Now is a function in SQL which will return the current date. So you can replace this with that database column field. For example, if I have a registration date, I will just put registration date over here, and this is the format as per date. Then it will display the registration date in this format. So you can do formatting as well using SQL statements. So SQL is a very powerful language based on relational algebra. So all the things which if you have studied relational algebra, those things can be applied over here. So SQL is a query language, structured query language, and we have well-defined formats. Select, we can specify the columns from the table, 1 table, 2 table, 3 tables. So depending upon the number of tables you want to retrieve, you can mention them, and then the conditions. What are the constraints? And so in structured query language, you can do it. We also have certain wildcard that we can use to retrieve information. Okay, for example, over here, like is another keyword which helps us to retrieve some information if we know the beginning or a few characters of a certain field. For example, like all the records that start with BER, all the records which have where city basically has ES in them. Okay. Similarly, if first letter is this one, third is this one, fourth and fifth are this one in a city, or any letter between A to C in a city. So these are the queries which and these are wildcards. Basically, we call them wildcards to capture the information. These are some examples that if this is the table, then these are the possible queries you can write on this table. Okay, see, price is greater than 5. This is a constraint. Description equal to this, which is a string. We have to put in quotes, or item number is less than 20. So any one of them becomes true, record would be returned. We have not sign as well in SQL. So where not price is less than 14. So if the price is greater than 14, it will be returned. So we look at them. Subqueries. Have you heard of subqueries before? Okay. So one query, which is subquery, can return some results which will be fed into the first query. Okay. So in this case, we are looking for employee details whose IDs are basically in. And again, in you can think of certain list which will be this is bracket. These brackets are for in. Okay. And with this in, we need the outcome from this query, which will be 1, 5, 6, 9, and 10, for example. So when those IDs will be returned, so when this ID from employee with salaries greater than 150, it will return some IDs, and those IDs will become input for this query. And against those IDs, we will get their details. So this is a subquery. And while we are writing this subquery, we can also apply certain constraints on subqueries based on the parent query. For example, if we can give alias to the tables, and when we are writing the second query, we can say that where salary is equal to parent query dot some value. Okay, so we can refer tables to apply certain constraints. Again, in your exam, I will not be asking about these things. Okay, if I would ask, it would be regarded to the basic stuff. I think we can take 10 minutes break, then we start with the joins. And again, I will not go into detail of these joins, I will simply briefly introduce you to them, and I will move forward. So we'll stop over here. Any question? No? Everything is good? Let me start the video.